Am I the only one that didn't know why a soccer ball just sits there until you kick it? Hey there, it is physics. Today we're diving into the fascinating world of motion with Newton's first law, also known as the law of inertia. Newton's first law tells us that objects like to keep doing what they're already doing. An object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. Imagine a tennis ball just chilling on the grass. It's not going to move on its own because it's perfectly content to stay right there. Now, let's say you decide to give a soccer ball a push. The moment your hand or foot applies a force to the ball, it starts to move. This is inertia in action. This is why when you're driving a car and you suddenly hit the brakes, you feel a jolt. The car wants to keep moving forward because of its inertia, but the brakes apply an external force that changes its motion. Inertia is also why astronauts float in space. In the microgravity environment of space, there's very little external force acting on them. Now, let's kick that soccer ball. Newton's first law also tells us that a moving object wants to keep moving in a straight line at the same speed. Ever notice how the ball eventually slows down and stops? That's because of forces like friction from the grass or friction with the ground and air resistance. Without those forces, the ball would keep rolling and rolling and rolling. Amazing. Inertia is a powerful force. It's a fundamental concept in physics that describes the resistance of any physical object to a change in its state of motion. This means that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. It's what makes it hard to start pushing a heavy box. When you try to move something heavy like a large box, you have to overcome its inertia. The box resists the change in its state of rest, and that's why you need to exert a significant amount of force to get it moving. Similarly, inertia is what makes it difficult to stop a speeding train. Once the train is in motion, it wants to stay in motion. The massive weight of the train means it has a lot of inertia, and it takes a tremendous amount of force to bring it to a halt. The more massive an object, the more inertia it has. This is why large industrial machinery, trucks, and ships require powerful engines and brakes to control their motion. The greater the mass, the greater the resistance to changes in motion. Think about it. Would you rather try to stop a bicycle or a bus rolling down a hill? The bicycle, being much lighter, has less inertia and is easier to stop. On the other hand, a bus rolling down a hill has significantly more mass and therefore much more inertia. Stopping it would require a much larger force. The bus has way more mass, so it has way more inertia. This is why larger vehicles need more powerful brakes and why they take longer to come to a stop compared to smaller vehicles. It would take a much larger force to change its motion. This principle is crucial in understanding how we design safety features in vehicles and machinery. That's why it's so important to wear your seatbelt in a car. In the event of a sudden stop or collision, may you be away from crushes, your body will continue moving forward due to inertia. The seatbelt provides the necessary force to counteract this motion and keep you safely in your seat. But we'll get to that in a bit. Understanding inertia helps us appreciate the importance of safety measures and the engineering behind them. It also gives us insight into the forces at play in our everyday lives, from the simple act of riding a bicycle to the complex operations of industrial machinery. Remember that soccer ball? It has a small mass, so it's relatively easy to get it moving. But a bowling ball with its larger mass has more inertia. You need to use more force to get the bowling ball rolling at the same speed as the soccer ball. That's inertia at work. Let's talk about cars. Imagine you're cruising down the road and suddenly you need to brake. Your car's inertia wants to keep moving forward. That's why you feel a jolt when you hit the brakes. Your body is still trying to move forward while the car is slowing down. Buckle up. Seatbelts and safety. This is where seatbelts come in. They're designed to protect you from your own inertia. When you wear a seatbelt, it connects you to the car. So, if you have to slam on the brakes, the seatbelt helps to slow you down along with the car. It prevents you from continuing to move forward and potentially getting injured. Inertia on the court and ice. Inertia isn't just about cars and seatbelts, it's everywhere in sports. In basketball, a player dribbling the ball has to overcome the ball's inertia to change its direction. In ice skating, a skater gliding across the ice will continue to glide in a straight line unless they use their skates to apply a force and change direction. Inertia is what makes those quick turns and changes in direction so impressive. Space travel. Newton's law beyond Earth. Newton's first law is crucial for understanding space travel. In the vacuum of space, there is no air resistance or friction. Once a spacecraft is set in motion, it will continue to travel at a constant speed and in a straight line forever unless acted upon by a force, like gravity from a planet or a boost from its engines. Inertia, a force in our daily lives. It's a concept that we encounter every single day, often without even realizing it. Whether you're playing a sport, driving a car, or watching a rocket launch into space, inertia is at play. So there you have it, Newton's first law in a nutshell. This law states that an object at rest will stay at rest, and an object in motion will stay in motion, unless acted upon by an external force. It's a simple yet profound principle that explains so much about the world around us. It's a fundamental principle that governs the motion of objects all around us, from soccer balls to spaceships. When you kick a soccer ball, it doesn't just stop immediately. It keeps moving until friction with the ground or another force slows it down. Similarly, a car will continue to move forward unless you apply the brakes. Remember, inertia is the tendency of an object to resist changes in its motion. This resistance is why you feel a jolt when a car suddenly stops or accelerates. It's also why astronauts float in space. Without gravity or another force acting on them, they continue to move in the same direction. It's why we wear seatbelts, to protect ourselves from the sudden changes in motion that can occur during a car ride. Seatbelts help to counteract the effects of inertia, keeping us safely in our seats. Why it's hard to stop a heavy object? Because the more massive an object is, the more inertia it has. This means it requires more force to change its motion. Think about trying to stop a rolling boulder versus a small rock. The boulder is much harder to stop because it has more inertia. And why spacecraft can coast through space. In the vacuum of space, there are no forces like air resistance or friction to slow them down, so they can travel vast distances with minimal fuel. This principle is crucial for space exploration, allowing us to send probes and satellites far beyond our planet. Next time you see something in motion, think about Newton's first law and the power of inertia. It's a fascinating concept that helps us understand the behavior of objects in our everyday lives and in the vast expanse of space. Keep those brains buzzing. Physics is fun. It is physics.